handout, the very first box is this ugly looking definition. We're going to see this several times. It's just this definition of a polynomial, what it means to be a polynomial. And we've talked about polynomials before. We know that if it's a polynomial, you have terms added and subtracted. They're just powers of x. You can have coefficients. So the actual definition of a polynomial, you want to write this in on that line. F of x equals a sub n x to the n plus a sub n minus 1 to the x sub n minus 1. It looks really ugly, but all those a's represent are just numbers, and then you have x to a power. So all of those a's are real numbers. They can be any kind of real number. They can be fractions, decimals, radicals. But in a polynomial, we should add in all the powers, so maybe say all the exponents, powers of x, are whole numbers. Remember, whole numbers are 0, 1, 2, 3, 4. So you are not going to have a square root of x in this. You're not going to have an x to the negative 3 or the x to the 2.5 power. Your powers on your x are nice, pretty whole numbers. Yeah, see, everybody likes pretty numbers, right? Definition down. So a few things that we need to mention here. Underneath this box, we have degree. Do you know what the degree is? Yep. In the definition I gave you, that would have been n. Just be cautious. It doesn't have to be the first number written. Lots of times we do write our polynomials in decreasing powers, so highest power first, but we don't have to. So you should look at every term when you're trying to determine the highest exponent. The leading coefficient you know what that is?
Largest number?
Close. It's the number with the x that has the highest power. So, yeah. It's the coefficient of the term with highest power. So, in this scenario, it would have been that a sub n. Again, doesn't have to be the first one you see. Could be, doesn't have to. Then if I'm talking about the constant, what is that? Constant is a term without a variable. Okay. In our scenario, it would be that a sub 0. It's just a number by itself. You all right with these terms? So let's make sure we understand them. I've put a few polynomials on here. I want to give the degree, leading coefficient, and constant for each. So first one, what would be my degree? Highest power of x is 1. Leading coefficient, so since this is the term with the highest power, the leading coefficient is just the coefficient on that term, so that would be 5. The constant term
Is negative 1?
is -1. Alright, you guys do the second two here. The second one, it's still a polynomial because the square root is only over the 2, not the x itself. Degree should be 4. Leading coefficient, if I'm looking at that, it has power of 1. What's the constant on this one? 0. Good. Alright, last one. What is my degree? 3. It's not the first term. Leading coefficient? -1/2. Constant? It's 5. Alright. Are we okay with that part? Then let's move on then. If our function is just f of x equals 0, that's not very interesting, but we call that the 0 polynomial, and we say it has no degree. The reason being, 0 is the same as 0 times x, or 0 times x squared, or 0 times x cubed. So if it's just 0, there is no way you can tell me what the power of x should be, because I could put any power of x with it. Now, if it's any other constant, it's like f of x equals 3. 3 is the same as 3 times x to what power?
1.
Well, is 3 the same as 3x? What power would make this x disappear? Anything to the 0 power is 1. And so that is equivalent to 3. So if it's any other constant, we say it has degree 0. But if it's just 0 itself, we say it has no degree. Is that okay? Quadratics. What do I mean when I say quadratic? It has what in it? We've talked about quadratics this year already. It has an x squared. We did those on our last test. So it's of the form ax squared plus bx plus c. Okay, we have dealt with quadratics already. We reviewed factoring quadratics at the beginning of the year. We did transformations with quadratics on the last test. So we just keep bringing this topic back up. When I graph it, what does the graph look like? The graph is a parabola. When I'm talking about my parabolas, they are either going to open up or down, which will determine if they have a maximum or a minimum point. So if I'm talking about a parabola that opens up, this is a minimum. If my parabola opens down, it is a maximum. And another word for that maximum or minimum point is the vertex. You've probably heard that before. We used it in Algebra 2 a lot. So let's talk about graphics. We might see quadratics given in different forms. Standard form is that one that I gave you, the ax squared plus bx plus c. We've also seen when we were dealing with transformations, we were looking at it in what is actually called vertex form. The f of x equals a times x minus h squared plus k. So when we graph these, we were able to use our transformations. The nice thing about this form is if it's written like this, you automatically know the vertex just by looking at it. It's going to be that hk, that ordered pair. And then if you were to graph it, as long as it's in that form, then you could just do transformations like we've done in the past. So now we're going to get into graphing these things a little more.
What was the vertical one passing you the vertex?
Oh, I left that one off, didn't I? Sorry. Vertical line going through the vertex is called the axis of symmetry. Sorry, I didn't scroll down far enough. Thank you. So now let's graph. I'm going to put something up here. If I told you to graph this one just by plotting points, because is it written so that I could do transformations to graph this? No. So if I made you plot points to graph this, let's see how that works. Give me a number. What do you want to plug in? 0. Everybody likes 0. And that gives us -4. Okay, what else? 1. And I get 1 plus 4 minus 4. So that is a 1. 2. Then I would have 4 plus 8 minus 4. And we get 8. If I put in a 3, is this going to get bigger or smaller? Looks like it's still getting bigger. Is this enough? Are those 3 points enough to draw my graph? If it's a line, that would be plenty.
It's not.
It's not, and I don't see the actual shape of my graph yet, do I? Okay, let's try some negatives. If I put in -1, then I get 1 minus 4 minus 4, so -7. Okay, we still have to keep putting in some negatives, don't we? So let's try, we'll do -2 and -3, see what happens. If I put in -2, then I get 4 minus 8 minus 4. So -2 gives me -8. I put in -3, then I get 9 minus 12 minus 4. So -7. Now it's finally looking like a parabola. If I wanted to do one more, let's say I put in -4, then I get 16 minus 16 minus 4. So -4. So we definitely have a shape now. Okay, so the question is that a good way to graph it? We got there.
It's a long way.
It's a long way, right? We had to pick the right points. What if my vertex was at -2/3? Would you have ended up plugging in -2/3 and finding the exact value of the vertex? Probably not. So picking points is great if you can find your vertex, but it's a little dangerous because if your vertex isn't a nice integer value, it's very likely that you may not get it in exactly the right spot. So we need a better method. We can do transformations sometimes. Whoops. If I looked at B, we can do this one like we did on our last test. X squared, so 0 squared is 0, 1 squared is 1, 2 squared 4, negative 1, 1, negative 2, 4. So that's the parent function like we used to do. So then, what would my transformations do? It's gonna flip over the x, and that 2, it's like, depending on your perspective, if you're thinking it's outside so it's vertical, so it's like a vertical stretch, which is going to make our graph get skinny when we look at that. Okay. Easiest way to do that is really just going through. These are outside, so they're applying to the y. We can just take our y's times negative 2. So this is a y value of 0. 0 times negative 2 is still 0. Y value of 1. 1 times negative 2 is negative 2. Y value of 4. 4 times negative 2 is negative 8. Same thing over here. 1 times negative 2 is negative 2. 4 times negative 2 is negative 8. So we get this skinny upside down graph. I think I failed to do it on the first one, but I did also ask for the domain of range on this. So let's go ahead and do that real quick. What's the domain of this one? And that will always be the case. What is the range? Good. What about on part A? What's my domain? What's the range? Good. Alright, why don't you guys try to graph C using transformations and then give the domain. Bless you. We've got our parent function. What's our transformation?
Bounds on right.
Okay. So it should look like that. Domain. Range. Good.
I have a question.
Yeah.
On stuff like this, like on the test or something, do you want us to like say right?
Only if I say describe the transformation. Okay, so if it's written in this vertex form, it's not too bad to do. You notice on these, the vertex, we wrote on that slide that your vertex is HK. So on B, I'm not subtracting anything from my H, I'm not adding anything on the end, so my vertex is 0, 0. Is that what we got on our graph? On C, if you think about x minus h squared plus k, it means our h is 3, our k is negative 1. Is that where we got our vertex? Yeah. So you could have told the vertex just from looking at it, or you could draw a quick sketch. With those transformations, it doesn't take long. Now, we need to talk about what to do on a problem like part A that we had earlier. So if I want to find the vertex. Then we can use this formula. X is equal to opposite of B over 2A. Do you guys remember seeing that before? Okay. That tells us the X value of the vertex, and then we plug X in to get the Y value. So we use the formula to find our X, plug it in to get the Y. Then the axis of symmetry, it is just the vertical line going through, so it is just the X equals opposite of B over 2A. On the axis of symmetry, since it is a line, I do expect you to write the X equals part if I ask for that equation. Y-intercept, that is when, what? How do we find Y at?
The axis of symmetry is in the middle.
When we
So
graph
we'll
them.
get the other point on our side.
Yeah. And that y-intercept is that other point. So to find that, you just let x equals 0. So is this starting to ring some bells, maybe how you graphed them in Algebra 2? All right. So we're going to try this on the next view. All right, so we're going to find vertex, axis of symmetry, y-intercept, domain, and range. So it has to be written in standard form to use the opposite of B over 2A formula. So like on C in the previous example, if we wanted to use the formula to find vertex, we would have to multiply that out. So if it's written in vertex form, it's easier to just do transformations. If it's written in standard form, we can use the formula. So the x value is the opposite of B over 2A. What is my B? 2 over 2 times what's my A? So I get negative 2 over 2, which is negative 1. To find your y, you plug that in. So I get 1 minus 2 minus 5, which is negative 6. So the vertex is an ordered pair, negative 1, negative 6. The axis of symmetry is the vertical line going through the vertex, so it's x equals that x value. X equals negative 1. Y-intercept, how do we find that? Plug a 0 in for x, what do we get out? Negative 5. Or you could write it as an ordered pair if you wanted 0, negative 5. Okay. So let's plot these. Vertex, negative 1, negative 6. Y-intercept is at negative 5. Axis of symmetry, if you remember in Algebra 2, we usually just drew a dashed line going through the vertex. And then what we did is we took our y-intercept and reflected it over that line to get a third point on the graph. So if I look at my y-intercept, it's 1 away from my line, so if I reflect it to the other side, it goes 1 away on the other side. Minimum 3 points, that's enough there. We've got our vertex, so we could draw our graph. What's the domain? What's the range? Negative 6 with the bracket. Is the vertex a maximum or a minimum? Minimum. The parabola is opening up. How do you decide from the original equation if it'll open up or down?
The positive and negative.
Right. This x squared is negative, it flips it upside down. Otherwise it's open up. If I asked you to tell me like increasing, decreasing, could you? We did on the last test. This section of the graph is decreasing from negative infinity to negative 1. This section's increasing from negative 1 to infinity, excuse me. So we could answer any of those questions like we've done in the past. Is that okay? Oh, it's just a sloppy R. Alright. Let's do another one. So, right now, can you tell me, will this parabola open up or down? It'll have a maximum or minimum? Minimum. Okay. So let's find the vertex. So to get the x, we do opposite of b, so the opposite of negative 6, over 2 times a. So you get 6 over 6, which is 1. Then plug that in. So I get 3 minus 6 plus 7. So 4. So vertex is the order pair 1, 4. Axis of symmetry, x equals 1. Y-intercept, if you plug in a 0 for all of your x's, what do you get out? 7. Or if you chose, you could write it as an order pair, 0, 7.
Okay, so when you do your vertex, why do you use negative 6 centimeters?
I did the opposite of b,
Oh, okay.
so since b was a negative, it became positive. Other questions? So now if we draw a graph, my vertex is at 1, 4, axis, vertical line going through that. Y-intercept is at 7. Reflect that across the Y, or the axis of symmetry. We get our third point. Domain. Name of any positive infinity, right? It'll always be the same. It keeps going in both directions. So the range is
Bracket.
questions there. Let's go ahead and do the last graphing one and then stop for the day. Sound okay? So, will this one open up or down?
Down.
And it will have a maximum. Good. All right, so to find the vertex, opposite of b, so negative 8 over 2 times negative 2. So negative 8 over negative 4 is 2. Plug that in. So we get negative 8 plus 16 minus 3, which is 5. So vertex is 2, 5. Axis of symmetry, x equals 2. What's the y-intercept? Negative 3. Okay, so I plot that stuff. Okay, you need a third point, so if I look, my y-intercept is 2 away from the axis of symmetry, so you go 2 away the other direction. I just missed my point. And then attempt to draw a nice parabola, hopefully a little bit better than mine. Like that. Domain. Range. Be negative infinity, comma, 5 with a bracket, because we always go small to large. Alright, so this is our stopping point for today. There is a Math Excel assignment open. I think it's 12 questions. It is not due until Friday. Tomorrow I'm going to finish the section, but I am also going to give you a handout. So you know everything to finish the Math Excel. If you don't finish it today, that's okay. Just know that tomorrow I am going to give you some other homework as well. Okay?